Okay, let's talk about now how we can calculate the forward rate and par yield for a given bond. And let's denote this with an example in Excel. So first notice that I'm considering a bond with face value of $100 and the maturity is 10 years. We have this coupon rate and the zero rates suppose are given. So once we have this information, we can calculate what's the discount factor by applying our exponential formula. So we can calculate each of these discount factors for different years for 1 year. So basically this is the value of $1 at the end of 1 year. The second one is the value of the $1 at the end of 2 years, and this is for the 10 years. So remember how we can calculate the forward rates. We know the formula, and basically this the formula we are applying here tells us what's the interest rate from 1 year later on all the way to the second year. And this is actually a 1 year interest rates at a future time. And you can see that similarly we can calculate the forward rates for the other maturities in the future, again for 1 year time. And basically notice that here the future value, or in other words what type of how much cash we receive each year, is given by this face value times the coupon rate. So this is the dollar amount of the cash that we will receive each year. And of course at the end of the 10 years we will also receive a face value. So the present value here we can calculate for our cash flow is the coupon payments, and finally coupon payment plus the face value as well. So the par yield can be calculated using our regular formula. Remember, for the 10-year maturity, our par yield is given by 1 minus the discount factor for 10 years, and you need to divide it by the annuity all the way up to these 10 years. So the annuity here, if you look at the annuity formula, that's the sum of the discount factors for each of these years. So that's the present value of $1 you are receiving during the lifetime of this bond. And so not very complicated. By using this formula we obtain the par yield. And what should we expect? For this coupon rate, basically the present value of this whole cash flow should be equal to 100, which is the face value. And this is no surprise that we get this as 100. And on the other hand, the par yield can also be calculated for each of these years in order to construct the so-called par yield curve. And you can look at the formula here. Now for year 3, in order to get the par yield, I'm using 1 minus the 3-year discount factor, and then I'm summing the annuity of 3 years basically. And if you apply this formula for all of these years from 1 to 10, you can plot this as your par yield curve. And we can also see that actually the par yield curve and the forward curve are related to each other, but they are not the same. Okay, and because the forward, you can see that the forward curve has a steeper slope compared to the par yield curve. This is because of the behavior of the zero rates. So you can see that the spot rates are increasing, so we actually have a positively sloped yield curve, and the par yield curve represents actually the swap rates if you design a swap contract between the fixed payments versus the floating payments. So the floating payments here are actually represented by the forward rates, because the forward rates are implied by the current spot rates, and this is what we expect the interest rates to be in the future. So if you are trying to design a fair swap between the floating rate cash flow versus the fixed cash flow, the forward rates represent our expectations about the future interest rates at time 0. And the par yields show the equivalent amount of the fixed payments that you can use in a swap contract. And finally, you can notice the yield to maturity applies to all the cash flows, and when you calculate the discounted cash flows with respect to the same yield to maturity, the sum should be equal to the market price. Okay, so here this is just an hypothetical market price I'm writing, but if you want to make it this equal to 100, then you need to reduce this yield a little bit more. For example, you can see that if I set my yield to maturity as, let's say, 80, it is getting closer to 100. So you can see that if we make the yield, let's say, a bit lower, like 70, maybe 7, our market value of this bond is getting closer to 100. Okay, so you can actually change this, but later we will see how we can use a solver or built-in functions in MATLAB or some other packages in order to obtain the exact value of the yield to maturity that makes this quantity equal to the market price that we observe. Okay, so that will come later on.